To the video for percents. I want to talk about percents, kind of in a historical context. They really predated decimals. Um, the percents go back to the Roman Empire. Um, decimals, as we know them, indicating portions, um, tenths, hundredths, anything what we would call past the decimal point. Really didn't come into being until about the 1200s. Uh, it really wasn't commonly used until the 1700s. Um, they were kind of a new thing. Um, Benjamin Franklin really liked them. That's how the American currency ended up being a decimal currency. Um, England did all its currencies based on fractions, and they didn't really change until the 1960s. Um, So decimals were really just kind of a new thing. Through the Middle Ages, percents were really how things were used, or percents were really how people addressed the problem of uh, not being able to do any more division, getting to the end and not being able to do any more. So percents really were a way to uh, make up for the fact that they didn't have decimals. So the Middle Ages made me think about Baa Baa Black Sheep. So sheep were a big deal back then. If you were looking at herds of sheep, and you had to compare a herd of 37 sheep with 5 black sheep, and a herd of 59 sheep with 7 black sheep, assuming black sheep were more valuable because the Middle Ages dyes weren't as common as they were later in history. So you had to compare those two. Technically, you would get a common denominator, and hopefully, a lot of you noticed that I chose prime numbers. So it would be hard to get a common denominator, and you could do it though. But then you suppose you have to compare it to a flock with 9 black sheep and 79 total sheep. Um, you know, you would have to go through that whole process again. Percents are a way to approximate fractions, um, and use a common denominator that's very common. And that's one of the reasons percents are still used. Percents are basically a fraction of 100. Um, and it gives us a common way to do things. So really, if you're using percent, you would compare that to a fraction, which is over 100. And as I talked about in other videos, when you have um, equivalent fractions, but you have kind of weird denominators, if you have 2/3 and you want to know how many sixths, you take your 6 divided by 3 and you multiply by 2. So instead of doing that here, I'm going to take my 100 divided by 37 and multiply by 5. So if you're trying to find x without a calculator, you can do 37 divided by 500. If we were using decimals, we would just put a point and then the 2 zeros. Percents are a handy way uh, to get uh, some extra zeros. So I do 37 into 50. That goes one time. Gives me 13. And now I bring down my other 0. And I look at my 37. 40 times 3 would give me 127. I'm sorry, 40 times 3. would give me 120. So I'm going to try 3 here. 3 times 37, 90 plus 21, 111, which is going to leave me 19. So I have 13, and we'll say a remainder of 19. X equals 13 and 19/37. We're doing the same thing with our 7 and 59. I can just go straight to my 59, divide it into 700, and I get 1. Again, 59 leaves me 11, and 110. That only gives me 11, or I can only put 1, so I have 59. And it's 41, 51. So here I have the number of black sheep equals 59. Sorry, 11 and 59. 51 59ths. And as you can see, I don't really need to compare the fractions anymore because I know that I have more than 13% in this flock and I have less than 12% in this flock. So that's really where percents came from. We don't really need them for that now. We could do the same thing with decimals now that we have calculators. Decimals are a good way to do things. But percents were a good way to compare numbers before calculators. One interesting thing about percents, if you have 12% and you add 8%, that's really 12 over 100 plus 8 over 100. You already have a common denominator. You get 20 over 100, which just gives you 20%. So if you're adding percents, it's really like adding fractions with a common denominator. You don't need to worry about it too much. If you're multiplying percents, though, if you're inheriting some money and your part of the family gets 12% of the money, and there are enough people in your family that you only get 8% of that, so you get 8% of 12%. So you have 12% times 8%. That's really 12 over 100 times 8 over 100. So you get 96 over 10,000. So you have to correct that. To actually get percents, you have to divide the numerator. You can multiply, but then you have to divide by 100. 96 divided by 100. Or you change one of them to a decimal. A little more complicated when you are multiplying percents, but really one option is to change them both to a decimal, put it in a calculator, and then multiply your answer by 100 to get the percent. I'm going to bring my calculator up here because I want to talk about how we actually use percents. That's kind of where percents come from, kind of the idea behind percents, why they work so nicely. But really, in the end, we want to just use a calculator. This is career math. You're always going to use a calculator in your career. I don't really worry about it. So, got a lot of problems where we're doing percents. One of the most common is sale items. We have 15% off. So if I want to know how much I take off, I do 30, get a smaller pen, 39.98 times 0.15. We'll just automatically change it to a decimal. It's easy enough. 0.15 times 39.98. And that will round off to $6 because we uh, only use 2 decimal places, and the 7 is greater than 5. So that's 6.00. And then we subtract that from 39.98. Pretty straightforward. The problem most people seem to be having is with problems like this, where we have sale price is 39.98. What was the original price? Um, and it gets complicated. The problem is people tend to multiply the 0.15 times the 39.98 and then add the 6, um, which is gets you pretty close, but it's not exactly right because of the 0.15 really needs to be multiplied by the original price. To answer this question, we have to say 0.15. I need to give myself some room. Need to plan ahead here. We're going to say 0.15 is multiplied by the original price. And then we subtracted that from the original price to get 39.98. And there are a lot of different ways to think about this. I like to think about this as 1 times x. And now we're combining like terms, or you can think of it as using the distributive property. Combining like terms, we're really using the distributive property. I'm going to say this is the same as 1 minus 0.15 times x. And in terms of the story, if you're not feeling comfortable with the math, in terms of the story, uh, we're saying we took off 15%. Uh, we only paid 85%. So we're taking 100% minus 15%. So we take off 15%. We're going to pay 85% of the original price. So in terms of the story, that's basically how the math works out. Instead of multiplying 0.15 times x, we really just multiplied, and then subtracting from x, we really just multiplied 0.85 times x. That's handy though, because now I can just divide both sides by 0.85. And I go straight to the calculator, and I'm going to hit clear 5 times, as somebody suggested in the beginning of the class, and I'll just do 39.98 divided by 0.85, and I get the original price A really strange original price because I hit the wrong thing on the keyboard. So I have to do it over again. 1, 2, 3, 4, 5. 39.98 divided by 0.85, and I get 47.04. My original price was 47.04.